Thank you very much. It's a pleasure to be here, and I love hearing high-tech dad jokes. That's a great way to start my day, and I'm very grateful to the organizing committee for accommodating me. I did have a plane ticket and a hotel reservation to be there with you today, but I'm becoming a U.S. citizen today. So when USCIS calls, you can't really reschedule it without risking a multi-year delay. So that was very nice of them to accommodate me here. I also want to mention, just apropos the last speaker, if you are interested in birds in Austin, my pal, the science fiction writer and environmental lawyer in Austin, Christopher Brown, has a stupendous newsletter called Field Notes that is mostly about Austin birds, and I strongly recommend it to you if you want to go and just have a quick search there and find it out. So, really, what I want to talk about today is not birds or US citizenship or even Austin. It really is about this quote from my pal Tom Eastman, who's a software developer, free software developer in New Zealand, who had this viral tweet in 2018. It goes, I'm old enough to remember when the internet wasn't a group of 5 websites, each consisting of screenshots of text from the other 4. And this may seem a little familiar to you. There's lots of theorizing in economic and tech circles about how we ended up with this winner take all technology, how the big weird web became 5 giant websites filled with screenshots of text from the other 4. When you hear economists talk about it, they tend to delve into something called network effects. Network effects are what you get when you have a service that improves or becomes more valuable every time someone uses it. So, you joined Facebook because there were people there who made it valuable to you. Once you joined Facebook, you made Facebook valuable to other people. And it's 100% true. That is a really important way that technology scales up. It is how big tech got big, but it's not how big tech stayed big. After all, there were network effects for like Alta Vista and DEC and Cray and SGI and lots of other companies that are sort of on the scrap heap of history. Ask Jeeves had network effects. So the question is not how did they get big, but why have they stayed big? Why has the circle of interruption and disruption been displaced? And I think that's down to another idea out of economics, one that we don't hear nearly enough about, and that's switching costs. Switching costs are everything you have to give up when you leave a service. So maybe network effects are what brought you into Facebook, but the switching costs of leaving Facebook are leaving behind all the friends you have there, the community you have there, the customers you have there, the family you have there, the family photos you've uploaded. Those are all your switching costs. And as you know, because you're software developers, those switching costs are completely artificial. They were engineered into the system. They're not organic. They didn't arise because somehow Facebook figured out how to make a service that you can't leave but continue to use, right? Where you leave but you can't take your photos with you, or you leave but you can't exchange messages with the people who you left behind. That interoperability that lowers switching costs, that's only being blocked, not because Facebook invented an interop proof service, but because Facebook figured out how to abuse the law to sue people who add interoperability to Facebook. So that includes projects like Ad Observer, where Facebook users automatically gather all the ads that they see and submit them to a repo so that researchers can go in and see whether Facebook is upholding its promise to block paid disinformation, or services like Friendly Browser or Power Ventures that are an overlay to Facebook that let you merge your Facebook messages with messages from other services, or block ads, or do other things like impose your own moderation policies that make Facebook better for you. Facebook set out to obliterate the ability for third parties to make the switching costs lower, not through technology, but through law. Interop is a way to take the users that big tech has held hostage and release them by blowing a hole in the walled garden. And we have laws now that are trying to unwind the legal barriers around interop. So in the US, there's something called the Access Act. In the European Union, there's something called the Digital Markets Act. Both of them stand a pretty good chance of passing. Certainly the DMA, the European law, is all but certain to pass. And both of them impose a kind of interoperability mandate on these big tech companies. And they try to define them pretty narrowly. It's, companies with billions of dollars in revenue, hundreds of millions of users, and millions of business users, and so on. So it's not going to affect your own hobby site, even if you become very, very successful. It's only going to affect this small handful of companies that have really captured the tech world. And what they both do, these laws and other laws proposed in the UK and Canada and India and Australia and elsewhere, what they all do is they basically say you have to expose an API, big tech company, that will allow third parties to gain access to the service so that users who leave can continue to remain in contact with the people they left behind and can continue to enjoy the value. So if someone stays on Facebook or within iOS or within any of the other walled gardens, they're there because that's the best service for them, not because they have to give up too much if they leave. But there's a problem with these laws, as much as I think they're a good idea, these interop mandates, which is that administering them is going to be really hard. Because one thing we know about these big tech companies is they would cheat if they're given a chance. Think about all those dumb opt-in messages you get for privacy under CCPA or the GDPR that are really not within the spirit of the law and are there to make you kind of give up on any pretense of expressing your privacy desires to these big companies. So they cheat when they can. And the problem is that if the way that these mandates are cheated on is by big companies saying, all right, we are going to expose this API, but whenever we think a bad actor is trying to exfiltrate millions of our users' records without their consent, our intrusion detection system or other automated security systems are going to shut down the API, either selectively or across the board, to protect our users. That's something we definitely want these big tech companies to do. It's actually a really important piece of anything that increases data flows, is empowering firms to act on behalf of their users and their users' integrity. But figuring out when Facebook shuts down its API because it thought that something really bad was going on, and when it shut down its API just because it wanted to mess with these interoperators, it's really hard. To a first approximation, everyone who is capable of crawling Facebook's server infra and figure out whether or not there was a real alert or whether Facebook was acting on a pretext, they all work for Facebook. And so this is going to be a long-term investigation, fact-intensive process that could take years to resolve. And if we're going to spend years figuring out whether a Facebook outage was caused by sabotage of a law or by a misfire in an IDS, and if they get to do it over and over again with delays of years before there's any reckoning or penalty for cheating, then you're going to see all the investors who back Facebook's rivals leaving behind those investments. You're going to see all the founders quitting. You're going to see all the users saying, I can't leave Facebook because when I go somewhere else, it just shuts down every couple of days, and there's nothing the services that I go to can do about it. And so we need something beyond just a mandate that forces tech companies to expose APIs if we're going to get interoperability, lower switching costs, and free the hostages of the walled garden. And I think that you folks can understand what that is. It's what we at the Electronic Frontier Foundation call adversarial interoperability. Actually, we used to call it that, and then no one could remember it or pronounce it. So now we call it competitive compatibility, or COMCOM. It's easier to say. Adversarial interoperability abbreviates to AI. That one's already taken. So COMCOM. COMCOM is reverse engineering, it's bots, it's scraping, it's doing all the things that you need to do to add interoperability to an existing service without having to get permission from the people who made it. And so those catch-all terms have been a really big piece of the history of the industry. We just had a great speaker from IBM. The reason we got IBM PC clones is because of adversarial interoperability. My friend Tom Jennings, the guy who created FidoNet, was working for a company called Phoenix. He reverse engineered the BIOS ROMs that came with the IBM PC, and Phoenix made compatible ROMs that Dell, Compaq, and Gateway, and all those other PC companies put into their machines so that they could run interoperable OSs and interoperable hardware with IBM. It was what let Windows users take their Microsoft Office documents with them to the Mac and read them with pages and numbers in Keynote. It's what let Facebook enclose the web. It's what let Google index the web. All of this stuff where you have a new technology that plugs into an existing technology without permission. And COMCOM, if you're non-technical, when I give this talk to non-technical people, they tend to say, okay, well, COMCOM sounds like a good idea in theory, but in practice, these big companies, Facebook, Google, Apple, they're hiring all the great engineers. How is some hobbyist or some startup or some nonprofit or some co-op going to manage to get beyond those engineers and do scraping and reverse engineering and bots? But you folks understand why this is a winning proposition, because you understand foundations of computer science, that computers are universal, that the only computer we know how to make is the Turing complete von Neumann machine, the computer that can run all the programs we know how to write. This is why the big tech firms use law and not engineers when they want to block an interoperator. You know, when someone creates Ad Observer, Facebook doesn't respond to that by going to the building full of engineers and saying block Ad Observer. They go to the building full of lawyers next door and they say sue Ad Observer, because they know that the engineers getting involved in guerrilla warfare with other engineers who are reversing them and trying to bypass their heuristics, that that's a losing battle, and that it's going to produce a lot of unquantifiable risk. And if there's one thing big publicly traded companies don't like, it's unquantifiable risk. Like, do you remember a couple of months ago when Facebook put out its first quarter results and said, oh yeah, we lost some US users more than we thought that we would, and the capital markets responded by lopping $280 billion off of Facebook's market cap, the single largest drop of any company's market cap in the history of the planet Earth, right? Not only is that something that Facebook would like to avoid for lots of reasons, but it's also something that Facebook executives really, really want to avoid, because Facebook executives are mostly paid in stock. So when their stock price falls because they get an unpleasant shock because of guerrilla warfare happening on their platform, the people who made the call to cheat and break the API so that people had to resort to reverse engineering, those people suffer the most. And when they want to hire more engineers to try and fight with the people who are doing ComCom, they have to pay those engineers cash, because if they say, oh, we're going to pay you in stock options, the people that they're trying to recruit say, stock options in your company that just lost $280 billion? No thanks. I'll take cash on the barrelhead. So here's a real world example of how this can go, right? How it is that we can take mandates, which are strong but brittle, and ComCom, which is flexible but kind of indeterminate, where you have to keep reprogramming your bots to get around the IDS, how we can combine them together like two-part epoxy to make something that is both strong and flexible. It's an example from Massachusetts, the Bay State. In 2012, Massachusetts voters went to the polls and voted in a ballot initiative for automotive right to repair. And it said that car companies had to expose the diagnostic codes that moved around the wired network inside the car. It's called the CAN bus, so that independent mechanics could fix those cars, could diagnose and fix those cars. So the law passes, giant majority, 80%. Everyone in the Bay State is like, yeah, I should be able to choose who fixes my car. And immediately the automakers move all of that diagnostic information from the CAN bus to a wireless bus, right? System on a chip is like 26 cents. They can just fill the car with a bunch of little Wi-Fi cards that can transmit all that data around a wireless network. The wireless network has been carved out of the ballot initiative. Therefore, nothing happens for 8 years. For 8 years, everyone who takes a car to a mechanic is rolling the dice, because the mechanic gets it up on the lift and goes, ugh. It turns out that the diagnostic information I need is on the wireless network, not on the wired network. There's nothing I can do for you. Everyone who invests in mechanics or loans money to them, the bank managers, they learn not to give money to those mechanics. The mechanics exit the field and either go to work for the big automakers, or they just change jobs altogether. And so 8 years later, Bay Staters go back to the polls in 2020. Once again, 80% margin. They vote in favor of an automotive right to repair bill. It's just like the last one, except it says, you know, for avoidance of doubt, the thing that's important here is not whether the diagnostic message is on the wireless or the wired network, it's that you have to give people access to the diagnostic data. Well, they're still in court over this ballot initiative. It's been 2 years since then. It's now been a full decade since we had the first right to repair ballot, and we're still nowhere. So what can we do to fix this? Well, imagine if there had been protection for ComCom, if there had been an interoperator's defense that would have safeguarded the people who tried to restore the principle of interoperability to these cars after the manufacturers subverted the mandate. Then you could have gotten like 3 smart MIT kids who just reverse engineered those error messages on the wireless bus and made a little gadget with like a cost of materials of like $4, had it manufactured in bulk in Guangzhou, had a couple of shipping containers worth of them shipped to the port of Los Angeles, and sold them all over America at $100 a pop. Not only that, they could have raised investment capital that would have let them offer warranty service, direct ordering for third-party spares, all the stuff that the car makers really hate, that they're really afraid of, that would erode their highest margin businesses. If that was the case, well, you would think that rational car execs would have not subverted the mandate. But say they were irrational. I mean, no one ever lost money by betting on the venality and self-destructive greed of corporate executives. Well, in that case, we would have been able to fix it with ComCom. So that is how we can fix this stuff with both ComCom and with tech mandates. But getting ComCom is going to be hard. There's a lot of laws that stand in the way of ComCom. There's the Digital Millennium Copyright Act that blocks reverse engineering. There's a Computer Fraud and Abuse Act that punishes violating terms of service. There's contractual terms and ideas like tortious interference with contract that companies use to attack third parties. There's software patents, all of this stuff, and getting rid of all these laws or fixing all of these laws, that's a big lift. It's a multi-year project. But we don't have to get rid of all these laws to make the world safe for ComCom. Like, there are other things we can do. For one thing, we can pass the Access Act and the DMA. We can wait for these companies to cheat on them, because they're gonna cheat on them. And then as part of the settlement and their punishment, we can say, hey, guess what? You're now subject to oversight by a special master. And if you ever want to bring a lawsuit against a third party for reverse engineering, you have to satisfy that special master that it's not a pretext to block interoperability. And if your adult supervision says that you're just cheating again, you don't get to bring the lawsuit. We can make that a condition of the settlements that we make in the antitrust cases that have been brought in the States and federally against these firms, as well as in Europe. And then finally, there's another good one, which is we could make it an element of government procurement. You know, this has been a part of good, prudent government procurement since, well, forever. You know, when Abraham Lincoln was outfitting the Union Army with rifles, he told all the rifle makers who were supplying the army, you have to use standard tooling and you have to use standard ammo, for like completely obvious reasons, right? Sorry, we can't fight the battle today. Our single supplier decided not to make bullets this month, right? So that is not a policy we've had since, and it's pretty bad in military spending, but it's bad all across the board. I mean, there should never be a car in a government motor pool unless the manufacturer promises not to block interoperators who make third-party spares or affect third-party repairs. Same goes for like Google Classroom being bought by your kid's school district, and all the rest of the technology in the stack should be procured in this way. And once Uncle Sam and all the state and municipal governments are insisting on interop, maintaining two different kinds of supply chains is going to be really hard. And so there's going to be leakage into the rest of the world. So irrespective of how we restore ComCom, we should do it. It's the mechanism that stabilizes interop mandates and makes them administratable. And interop, just to remind you, is how we make switching costs low. And making switching costs low is how we restore the wild and amazing internet and banish this bizarre world of 5 giant websites filled with screenshots of the other 4 to where it belongs, the scrap heap of history. So thank you very much for listening to me. Wish me luck on my citizenship exam. And I hope to see you all next year in BC, where I think I'm going to be a keynote there. And so maybe I'll show off my new US passport to you when we all see each other in person.
That'd be great. Thank you, Cory. Hopefully,
thank you. Good luck.